Have you ever heard the term polynomial and not been sure of what it meant? Well, I'm Veer Mahajan, and in this video, I'm going to explain to you what polynomials are. I'll explain the definition, show you examples, then I'll show you how to sort polynomials by degree and the number of terms, show you how to write polynomials in standard form, and also show you how to simplify polynomials by combining like terms inside. So let's just go over a quick description of what a polynomial is. So let me write that here. Polynomial. So poly, hopefully you recognize this word from other words. It's poly basically means many, and nomial is like names. So names. However, in this case, it's not exactly names. Names are similar to terms, so it's just terms. So many different terms in a polynomial, and of course you can change this to make. We can change the poly to make it like bi, which is 2. So 2 terms, and then mo for 1, and then 1 term, tri for 3, and then the 3 terms. But I'll talk about that a bit later. I know that wasn't a really detailed description. It isn't a proper description of a polynomial. I'll give the actual definition. It's basically an expression which is made up of variables with coefficients and positive integer powers, and the coefficients and the constants, they're also real numbers. So let's just take a look at an example of a polynomial. And I've written down the rules here, so if you ever want to check if something's a polynomial, you can just check all of this. This just shows that both of these are real numbers. So you can just look at this thing on the right. Let's go with x squared. So it needs to meet all of these criteria. So it definitely has a variable, that's x. It has a non-negative integer exponent. If I said earlier that it has to be a positive exponent, that's wrong, I apologize. It's just a non-negative integer exponent, so it can also be 0. So x squared, so yeah, we have that non-negative integer exponent. We don't have a coefficient yet, and we don't have a constant. But we can do that very simply by taking this 1x squared, which is the same as x squared, and we can add a 0. It's the same value as x squared. It's simplified because the 0 shouldn't come, the 1 doesn't need to come either. But now it has a constant, the 0, a real number, 1, a coefficient, which is also a real number. So this is a polynomial. Now let's go with just go with 0. Is this a polynomial? Well, it actually is, and the way we can show that is just by saying we can first of all make this 0, as I showed before. I don't think I showed it yet, but we can just put any variable to the power 0. This is always 1. So if this is like 5 and you want to show that as a variable with an exponent and coefficient, you can just add any variable to the power 0 because that's always 1, and then the original constant just becomes a coefficient, and then it's equal to the coefficient, the value of that, because anything to the power 0 is 1 apart from 0. But over here we can just show that. So now it's got and we can add a 0 over here as well. So now we've got a constant, we've got a coefficient, a real number 0, an exponent, a non-negative integer, it's 0, and we've got the variable x. So even 0, it works, right? So this also works. But now let me show you some examples of ones which are not actually polynomials, and I'm not going to immediately explain why. I'm just going to write it down and read it aloud, and then if you want, you should try to pause the video and see if you can, using these rules, show why it isn't an actual polynomial. So let me give you the first example. So y root x plus 3. This is not a polynomial, but why isn't it a polynomial? So just I'll give you a few seconds break. Just pause the video and try it yourself. Okay, so I hope you tried it. The reason is because root x, when you put a radical on top of a variable in a polynomial, that doesn't work. That never works, because root x, the square root of x, is the same as x to the power 1/2. Oops, 1/2. And 1/2, it has to be a non-negative integer. 1/2 is not an integer. So this does not work. So this entire thing is, that entire expression is not a polynomial. What about What about 1 over x cubed plus 4? This is also not one this is not a polynomial, but y isn't a polynomial. Again, I'll give you a few seconds pause and then try to find it yourself. Okay, the reason is because you can never actually have something like this where you have the variable raised to the power of exponent. Basically, the variable, it shouldn't be the denominator, and the reason is because, like, at least in this case, it shouldn't happen because 1 over x cubed is the same as x to the power negative 3, right? Because the negative just makes it the reciprocal of that, so that's a reciprocal. Instead of x cubed, it's just 1 over x cubed, and that's the same as x to the power negative 3. And it has to be a non-negative integer, and this is a negative integer, so that doesn't work. That's why this example doesn't work either. Now, let's move on to just showing you. I'll just show you how to classify polynomials by the number of terms in them, and I'll also talk about what terms are because I haven't really covered that. So, in a polynomial, I should have also mentioned this earlier, but it's an expression which consists of these, and all of them which consist of different terms, and all of them are added to each other. So, x squared plus y squared minus 4z cubed plus 8. These are all the different terms. Why? Because they're split by plus signs. Okay? So this is a plus sign. This, we can add a plus sign here. Plus negative 4z cubed is the same as minus 4z cubed. So we have another plus sign over here and another one here. So this is one term. Negative 4z cubed. So that you need to remember that there's a negative over here. That's one of the terms. There's also x squared, y squared, negative 4z cubed, and 8. So these are all the terms which are separated by the plus signs, which is just an easy way to check how many terms are. And based on the number of terms over here, the polynomials have specific names. Not always, but a lot of them have specific names. So if there's one term, for example, x squared, that there's only one term in this polynomial, equals one term. So I'll just write that here. And this is called a monomial. MO, that's like one, like in a monocycle, that's with one wheel. So mono, that's one name, one term, right? In the beginning it was polynomials, which is many terms. This time it's one term. X squared, y squared plus 4. We have x squared, y squared, that's just one term. It's not two different terms, it's just one term. Because there's one plus over here, so that separates the two. This has two terms. So it's a binomial. Bi means two, like in bicycle. So two terms. And then with like x plus y plus z, we have three terms, x, y, and z. So this is going to be a trinomial. Tricycle, and it means three, so three terms. And anything more than that, that's just a polynomial because they don't have specific names for any other. So if it's more than 3 with 4 or more, then it's just going to be a normal polynomial. We can also classify them by degree. And degree is basically, it's not too complicated. If it sounds complicated, don't worry, it's actually not too hard. I'll give you an example. X cubed. X cubed plus y squared minus 4. That's basically just the highest exponent. So let me write over here as a note. So degree equals highest power. I'll just go with power for now. So highest power, and obviously the powers have to be all non-negative because that's what happens in a polynomial. So here we have x to the power 3. So these are all the powers that we have. 3, here we have 2. This we can put any variable, let's just call it a to the power 0, right? Because a to the power 0, that's 1, so we're just left with that. So these are all of our exponents over here. So the degree of x cubed plus y squared minus 4 is going to be 3 because that's the highest out of all of these. But what if we have something like x cubed y fourth z squared minus 4 a to the 6th? Now which one is higher? Because this one has lots of different exponents. Well, if it has multiple exponents in one term, you just add them all up. So over here, even though it may seem like 4a to the negative 4a to the power 6 is the highest, excuse me, it actually isn't, because you add up all of these and when you add them all up, you get 9. So 9 is the highest. So the degree of x cubed y fourth z squared minus 4a to the power 6, a to the 6th, that's going to be 9. Okay, remember highest power, and you should always add them up if there are multiple powers in one term. So just add them up like that. And when you write polynomials in standard form, which is the general way to do it, basically what you do is you just write it in order of the degree. So you write, let's say you have x squared minus y cubed plus 4z minus 37. Over here you just arrange it by the highest exponents. So over here we have z to the power 1. Here let's just call this z to the power 0, because that's also equal to 1. So that's keeps it as 37. What you do is organize it by the highest value exponents. So we have y cubed, and remember this is separating it like this. These are the separate terms. It might be confusing sometimes, but be careful because you might otherwise make a mistake. When you're rearranging it, if you forget the negative sign or you move it somewhere else, you will get questions wrong. So remember, this is not y cubed, this is negative y cubed. Okay, that's the first term. That's a term with the highest exponent, plus x squared, because it's got the power 2, plus this has got the power 1, so it's 4z, and we don't need to put power 1 because we already know that, minus just 37, and I'm going to put z to the power 0. And so that's just how you rearrange it and put it into standard form. So basically here all we did was switch these, but it might be more complicated later. So we put it into standard form, but what if we have z squared and all of this, but we also have a q to the power 3 minus all of this. Well, let's just put this in its own bracket. We'll add a plus sign here. I'll just quickly add one there and put a minus sign there instead. So we've now separated all these terms. Plus, oops. Okay, wait a second. I'll just make this a negative 37 so you can see what terms are what terms. So these are all of our different terms. And now let's look at all the exponents. There's 1 q to the power 3 x squared, negative y to the power 3. There are 2 3's. So what are we supposed to do now? Because this is negative y to the power 3, this is q to the power 3. But over here you can just decide, like if they ask you specifically to put in order, that you prioritize y first, then you put y cubed, negative y cubed, plus q cubed minus x squared plus 4z minus 37, you'll do that. But otherwise if you put it as q, then you just switch these two. And if there are multiple of them, you just do the same. And if there, let's see, but let me quickly show this now. If you have like 4y cubed, I'll just move the 4, that's just a bit extra right now. Y cubed x squared plus x cubed y squared. Right now what we have is both of these terms have a degree of 5. They have an exponent of 5, combined exponent of 5. This is 3 and this is 2, so this is a total of 5. Here we have 3, here we have 2, this is also a total of 5. You can, now they're both equal, but you can decide how you want to do that again. Since here, if you want to prioritize y first, like you want to put y higher, then you put this one first, because here y has a higher exponent. If you want to put x first, then you put x cubed y squared plus y cubed x squared, because then the x is the highest, has the highest exponent. So you can just, most of the time when they're multivariable terms, you can decide which way to order it in. Now let's just talk about simplifying polynomials. So far all of the ones that I showed you didn't really have anything where, like for example, x squared plus 4 minus x plus y squared minus x squared. I never showed you anything like this. And look, we have x squared here and a negative x squared. So you, lots of times in problems you might have to simplify polynomials. Like over here, x squared and negative x squared, if you just leave them, you might get some weird results. So just cancel them out. And basically any terms which have the same, okay, I'll write this here as well. Terms with the same variable and same exponent, and the exponent by default, by definition, has to be non-negative, has to be a non-negative integer. terms with the same variable and exponent are like terms. Wait a second, are like terms. So basically k to the power z, let's call this 5k to the power z, is a like term, and like 7k to the power z, these are both like terms because they have the same variable and they have the same exponent. And with like terms, what you do is you just add the coefficients. So for example, if you add like 5x squared, and then the next term was negative 3x squared, you just, these are the like terms, right? So you ignore that, you go to the coefficients and you add them up to get 2, and then you bring back the variable and the exponent to get 2x squared. So if you have 5 of something and negative 3 of something, you add them up, you get 2 of that same something. So basically that's how combining like terms works. So I hope you like this video. I hope you learned something new. And now next time if you hear polynomial, hopefully you'll be able to understand what it is, and just like remember all of these rules and some of these important facts over here. If you enjoyed this video, please hit the like button, and also consider subscribing so that you know when I make new videos. I also have a website where I make lots of practice problems, and I've got lots of other videos organized over there. The practice problems, educational slide decks, and a lot more over there. I'll link it in the description. Thank you for watching. Bye.